We produce waste every day. Huge mounds accumulate around city boundaries, shamefully hiding from our eyes, claiming more and more area. Fragments of foil, various foam bits produced from crude oil, are flying around. This waste is a testimonial to the imperfection of our civilization. Is there no remedy? Thanks to EU funds, Polish laboratories and institutes are conducting research on innovative materials that shall not accumulate in heaps for long years. They are to meet specific expectations but become degradable after fulfilling their purpose. The basis for producing such polymers are agricultural products. They become polymers after a few operations. Slowly, after many hours of work at the Center of Polymer and Carbon Materials in Zabrze, a white substance appears in the beaker. It will serve as the basis for the production of a new polymer, one which, thanks to the activity of bacteria and fungi, will degrade when no longer needed. Research on biodegradable polymers is conducted at the laboratories of the Center of Molecular and Macromolecular Studies. This inconspicuous granulate serves as the basis for the production of synthetic materials. Scientists from the Institute of Biopolymers and Chemical Fibers develop biodegradable nonwoven fabrics that find application in agriculture, medicine, filtering, and sanitary materials. A new device has been constructed at the main textile machine R&D center of Polmatex, Senaro. Presently, various nonwoven fabrics can be produced even in laboratories. Can bacteria and fungi handle this material? Still, other groups of scientists from the Institute of Biopolymers and Chemical Fibers are working on products which would become biodegradable after use. Yarn is formed of threads several micrometers in diameter. It can be used in manufacture of technical and medical products or clothing. In the biodegradation laboratory, samples of earth mixed with water are placed in big jars. They will act to simulate functions of microorganisms in the natural environment. Small samples of the innovative nonwoven fabrics are put in glass containers. Their examination commences. Air is now pressed to pass through the liquid. Analysis of the gas will enable to detect carbon dioxide emitted during the degradation of the nonwoven fabric initiated by the microorganisms. Following years of research at the Department of Material and Commodity Sciences and Textile Metrology of Łódź University of Technology, a new technology of electrospinning was designed. This method can be applied in the production of materials made of fibers several hundred nanometers in diameter. Similar nonwoven fabrics find application in medical products, for example in dressings, bone and skin implants. They can also be used for filtering dust or liquids. After a few months, such materials decompose. Bone implants and dressings from biodegradable nonwoven fabrics are tested at the Medical Academy in Wrocław. Also, biodegradable foams for medical application are produced at Łódź University of Technology. They can absorb several times more liquids than their own weight. Their asset is ability to maintain a moist microclimate. They degrade after several months. Microspheres and microcapsules made of biodegradable polymers can contain a given substance, for example medicines, which, thanks to polymer degradation, are released in small quantities into the organism over a longer period. Properties of materials can be altered thanks to saturation with microgranules. Depending on expectations, they can either repel or absorb water. A new production line for biodegradable foil for agriculture has been designed at the Department of Material and Commodity Sciences and Textile Metrology of Łódź University of Technology. Several thousand tons of similar foil and nonwoven fabrics are used in Poland annually. They protect crops from drying out. The usefulness of such foil has already been tested at the University of Agriculture in Kraków. These new products will also not accumulate at waste dumps for centuries. Another laboratory has developed the production of biodegradable twine for agricultural purposes. The string is used to underpin seedlings during vegetation. An item sought by plantation owners. When the season is over, microorganisms will turn it into mold without difficulty. New materials for medical purposes are created at the Textile Research Institute within the BIOGTATEX project. Biodegradable fibrous products are a chance for the environment.